Hey, what's up, everybody? Chris here. So, today I have a short video where I just want to walk you through some of the most recent changes that Pandas has made, specifically to their backend. So, just want to go through, kind of walk you through a notebook. It's going to be available in the description, and it's going to show off, how you can implement this new backend and how much quicker it is. So two caveats to start. Number one, Pandas is kind of a memed on tool or well and duly criticized tool for being kind of slow. This definitely helps. Does it fix everything? No, but Pandas is also a tool that's used in a ton of workflows. It's a very popular tool. It's especially when people are getting started in, kind of the machine learning or data science space. They're going to be leveraging Pandas a lot. And because of that, there's tons of pipelines in the world that kind of run on the back of Pandas. So that's kind of the motivation for the video. Secondly, I'm not going to go into at all the technical details of the changes. It's very dense, doesn't feel well suited for a short video, but I will link some resources that go more in depth to it. The big overview here is that Pandas switched their backend. Now, not fully or truly yet. They're still using the default backend they had before, which is built on NumPy. But we have the ability now to very quickly and easily change that and start using the PyArrow backend, which is built on Apache Arrow's, or built on Apache Arrow, sorry. And it's just an amazing tool. Apache Arrow makes kind of pulling in and pushing out data super fast while in memory. And that is obviously a huge benefit, for Pandas, right? Who's primarily in memory manipulating data, right? So having a backend that is extraordinarily well optimized for those kinds of operations where we need to pull data out, do something to it, and then push it back in, or just read it, or any operation, right, where we're needing to interact with our data, it's huge for Pandas, right? So this is walking through kind of how to start using the PyArrow backend in your Pandas projects or at work, and we'll just get right into it. So first things first, you have to make sure that you have the most recent version of Pandas, or at least 2.0, which you can just check with the pd.dunder version. As you can see here, we're running the 2.0.0 release candidate, so very exciting. So how do we actually take advantage of PyArrow? Like, how do we write the code, right? So normally when we build a series, we will just pass some values. You might be in the practice of using D types. And if you are, that's great. And so you're just going to be changing your D types. But if not, like by default, Pandas is going to infer which D type to use, right? So we see that when we pass in some numbers, we have the D type of int64. That's NumPy's implementation. And when we pass in some strings, we get object, right? So right away, we can tell that like that's awesome for numbers. It gets int64 D type, but our strings are getting object, right? So immediately we can kind of see there's room for improvement here. And that's where that PyArrow backend comes in, leveraging, again, the Apache Arrow system. So all we have to do when we're creating our series objects is pass this dtype parameter with the value, whatever we want it to be. In this case, we're going to use the PyArrow implementation of int64. And in the case of strings, we're going to use the PyArrow implementation of strings, right? So right away, we're kind of already, you can see why this might be advantageous, right? We're using a D type that is specific to our data. So, immediately, it is that easy to start using this, right? So already, we're just passing D type. And a lot of people are already doing this. So it's just, pointing it at PyArrow. So what's the benefit here, right? I'm just going to slide through some of this. Basically, we set up some series objects of, a couple million random strings. And then we looked at how fast it took to read in from the list to the data frame or the series object in Pandas. It's about the same for either implementation when we're talking about just loading it into a series. But once we have it in the series, that's where the magic starts happening. So, we'll look at just kind of a basic example here, which is, what if we had 2.5 million strings and we wanted to find all the strings that ended with A, right? Well, we can do that using the PyArrow backend exactly the same way that we would have used the traditional Pandas backend. And we can find that it's actually quite a bit faster to use the PyArrow backend. I mean, it's over 2 times faster, right? It's cutting that time in more than half. And that's huge. It's the same implementation between the two. All we did is we made sure when we created that series that we passed that D type as string PyArrow, right? And with that being the only difference between the two implementations, we get a speed increase of more than 2 times. So first of all, that's huge, right? And again, all we had to do was change the D type. So let's look at so we get why it might work with strings, right? We're using a specific data type with strings. So our string operations might be a little bit more optimized, but it's not just that, right? The whole idea with this backend change is that it's just allowing us to access our data quicker. So we're able to do that even when we're using numerical data, right? So in here, again, we have the same thing where we have we create a list of 2.5 million random floats, and then we save them both as float64, which is the default NumPy backend for Pandas, and then we pass in this D type of float64 PyArrow to enable the PyArrow backend. And right away, when we look at something as simple even as finding the mean, right? We can see that there's a speed up of, again, more than 2 times, right? It's cutting that time in half. That's huge, right? So when we think about time taken in computation, oftentimes what we're thinking about maybe is, so it's going to be quicker and that might be cheaper, and that's can be true. But, and maybe more importantly, think of how much of an increase this might be on an operation that's time sensitive, right? The fact that you're able to complete that task in half as much time makes it a little bit faster down the road, right? And if this happens at every step of your pipeline, then by the end, all of these cumulative changes will have added up to huge time savings on that pipeline, which very well might save you some money. It might save you some latency. So all in all, huge changes, right? There's an even bigger change, though. So now we have the ability to write and read in our data using this backend. Now, for the writing portion, since we're writing to a standardized format, your CSVs, your Parquets, whatever you're choosing to write out in, there's no performance gain, right? This is the PyArrow implementation is primarily concerned with in-memory operations. So it's not like, the data is going to take up less space on your hard drive, but it does impact how quickly you can ingest that data. So let's look at the example here where we basically want to read a CSV, right? And we want to take advantage of that PyArrow backend. So there's a couple things we have to be sure we do. First and foremost, we need to make sure that we specify that we want our D-type backend to be PyArrow. So this makes sure that we're using that PyArrow backend whenever we're completing an operation. Secondly, when we read the CSV, we want to make sure we're using the PyArrow engine to do that, right? So again, this is so far we've typed 1 line of code and we've added a parameter. And then this is just a product of right now. I'm sure in the future this will be different, but for right now, you also must pass this use nullable D types equals true parameter. And I'm going to link an article that kind of goes into why that's even coming up. But basically, the PyArrow backend or Apache Arrow just works better for nulls. And so there's some advantages there as well. But again, that's kind of in the nitty gritty. So we'll leave that to the excellent article that someone wrote that explains this very well. But with this change, right? So we added one line, which was telling Pandas, hey, Pandas, please use PyArrow as your backend for D types. And then when we read the CSV, we said, hey, use the PyArrow engine. And then we passed this extra parameter, which is just at this point required. You can see that just that change alone gave us a speed increase of more than 8 times. It was 8 times faster, right? Just for making those couple changes. So that's huge. And that's applicable in any project in which you're ingesting data into a series object or a data frame. It is absolutely free. I mean, they worked so hard in order to ensure that there's no breaking changes that in all likelihood, this is going to be a plug and play, switch for whatever projects you're working on. Test, make sure you test, make sure everything is working good if you do make the switch. But yeah, I mean, this is incredible, right? 8 times faster for what amounts to essentially 2 extra lines of code is insane, right? And it's, again, beyond just you ingest faster. Every operation you do is going to be faster. So the speed increase, that the downstream speed increase is also huge. All of this to say, and all of this to showcase, the changes to Pandas are very impactful and very easy to implement. So if you have any projects or you're working with a ton of data and you have to be using Pandas to do that, I definitely recommend getting 2.0 and leveraging these PyArrow changes. Thanks so much for your time. Hope you enjoyed the video. If you did, if you could press the like button or comment or whatever, I know, so cringe, but it is what it is. Thank you so much. Have a great day, and we'll see you in the next one.